back to word problems. Now we're going to be talking about distance problems, and let's get to it. Here we got Karen made a trip to the lake and back. On the trip there, she drove 68 kilometers per hour. On the return trip, she went 51 kilometers an hour. The question is, how long did the trip take if the return trip took 4 hours? Best thing to do is to make a little chart. So we'll make a quick chart here. Make it into 3 parts. And we'll be using our distance is equal to the rate multiplied by the time. In this case, by the way, the rate is an average rate or an average speed. So let's see. This would be the trip there, and then this will be the return trip. Okay. R, T, and D. The way there, she drove at 68 kilometers an hour, so that can go there. On the way back, she drove at 51 kilometers an hour. But let's be careful how we read the question here. It says, how long did the trip take if the return trip took 4 hours? So that means I can use that in this part, and I can solve for D here. So D will be equal to 4 multiplied by 51, and then 4 times 51 would be 204. So that means our distance is 204. By the way, 204 will be the same for both, since it is the same distance going there and coming back. The question is, how long did the trip take to get there? Well, that's also very simple, since we have an equation here that has distance, it has rate, and we're just got to find out what the time is. So we could set up an equation. We can say that 204 is exactly equal to 68 multiplied by some unknown time. And if we divide both sides by 68, then T will be equal to exactly 3 hours, 3.0 hours. Okay, so that's not too bad. Of course, it can always get more difficult as we move along. So let's try the next problem ahead. Okay, so here we got a jet. A jet flew to Las Vegas and back. The trip there took 5 hours, and the trip back took 3 hours. What was the jet's average speed on the trip there if it averaged 300 kilometers an hour on the return trip? Okay. Again, it would help if we made a chart quickly. It shouldn't take very long. Here we go. This is going to be the same formula. Rate multiplied by time equals distance, also known as the RTD equation. Distance equals rate times time. And here we go. So again, we label this as going there and coming back. Okay. Of course, it's always helpful to read the question a few times until you really understand what is being asked. So here we go. Let's see. The trip there took 5 hours. So that means I'm going to put 5 here. The trip back took 3 hours. I'm going to put 3 here. Okay. What was the jet's average speed on the trip there if the average speed, the average, if it averaged 300 kilometers an hour on the return trip. Okay, the return trip, that means I have to put 300 kilometers per hour here. Well, that means that all I have to do is find the distance here, but then that's just multiplication, because distance becomes 3 times 300, which of course is 900 kilometers. So I'm going to put 900 here, and since the distances are equal on the way there and on the way back, all we got to do is solve for the rate for the second part, which says what was the jet's average speed on the trip there, right? So this is what we're looking for. So we're going to put in 5 times the rate is equal to 900, and divide both sides by 5. Clearly gives us the rate is equal to 5 goes into 900 180 times, or 180 kilometers per hour. Very straightforward. The thing is, you just have to learn how to read the question. I can't emphasize that enough. So I have 2 more problems. Let's go to the next problem. You can always pause it and review the question over and over again until you finally get it. Alright, so here we go. Let me make this one a little bit bigger because it's hard to read. Let's see if I can enlarge that a little bit. That works. Alright, so we have a freight train starts from Los Angeles and heads for Chicago at 40 miles per hour. 2 hours later, a passenger train leaves the same station for Chicago, traveling at 60 miles per hour. How much time will it take before the passenger train overtakes the freight train? Okay, this one you really have to be careful, because you have to make a nice chart, because they don't leave at the same time. They have different times now. So let's do our table. It always helps to make a table. Rate, time, distance, and we're going to call this the freight train, and then this will be the passenger train. Okay, so for the passenger train, it says it leaves at a certain time unknown, call it R, right? And it takes, wait, let me go back a second. It leaves at a certain time T, correct? And it's traveling at 60 miles per hour. The freight train left 2 hours earlier, because if you can see, it leaves first, and then 2 hours later the passenger train leaves. So this is going to be already ahead by 2. So we're going to put here T plus 2, but traveling slower. Okay? Now, since they're traveling, let me draw a little line here. Starts here, one goes there, the other one starts here and is traveling this way, but eventually both of them will have to be at the same point. Therefore the distances must be equal. So we can set an equation saying that 40 multiplied by the rate, which is t plus 2, must be exactly equal to the other rate. You can multiply 60t here, 40 times t plus 2, so this will be equal to 60t, and then we can solve the equation and solve for time. Alright, so this gives me 40t plus 40 times 2 is 80, obviously, equal to 60t. Subtracting 60 from here and subtracting 80 from there, that's going to give me, or just subtract 40 from both sides, actually. It's easier this way. Minus 40t, minus 40t. This go away, and I get an equation that says 60 minus 40, which is 20. T equals 80. And t just becomes 80 divided by 20 divided by 10, so 8 divided by 2 is 4. So the time it takes for them to catch up is really 4 hours. Pretty straightforward. Please go over the problem as many times as you need to. I think I have one more problem and almost running out of time here. Let's move it along. This one looks a little too small. Let me make that a little bit bigger. How's that? Much better. Alright, so we have two planes leave an airport at the same time. One headed east, the other west. The first one is traveling at 600 miles per hour east. The second is traveling at 150 miles per hour west. How much time will it take for them to be 900 miles apart from each other? Let me change colors real quick. Try red. Okay, so if we now see that both planes are traveling in opposite directions, the distance traveled is what we are going to use. Total distance equals rate times time. Now, one of the planes is traveling at 150 miles per hour, going one direction. The other one is moving away at the opposite direction at 600 miles per hour. And using the formula for each one, this one will be 600 multiplied by the time, and the other one will be 150 multiplied by the time. However, because the distance is increasing as they move apart, you have to add both of these, and that gives me the total distance that will be away from each other. So if you add those two together, you end up with 600 plus another 150 would be 750 times t, and we want them to be 900 miles totally apart. So 900 goes there, and obviously t will be 900 divided by 750, which gives us 1 hour and 1/5 hours total.